Hello everyone and welcome back to science class. Today we are starting on a topic that's very different from what we were talking about last time, and that is climate change. So before we get into the actual nitty-gritty facts about climate change, let's talk about the difference between weather and climate. So weather is something that we experience in our day-to-day lives. It's the weather conditions outside that happen in a small area at a very particular time. So for instance, today it's pretty cold out, but it's also pretty sunny. So that's the weather today in the region that I'm in. Now, climate describes the weather conditions in a very large region at particular times of the year. So typically seasonal changes and that kind of stuff. There are 5 main types of climate. There's polar, there's temperate, there's dry, there's tropical, and then finally there's continental. I'm going to be using my globe here to kind of like show you where each of these regions kind of lie. So polar typically is right at the north and right at the very south. And a polar climate is particularly cold all year round. Polar climates can also be found where there are tall mountains, such as the Himalayas, right here in Asia, or in the Rockies in North America. And if you look at South America, we have the Andes. So polar climates can be in very tall mountains as well as the polar regions of the Earth. Next, we have temperate areas. Temperate areas tend to be close to the equator, but not directly on the equator. They tend to be a little bit more above and below. And they tend to experience what we call the 4 different seasons. So they have a very distinct summer, a very distinct fall, a very distinct winter, and a very distinct spring. Their summers are typically warm and humid, and they typically have mild winters. Dry climates don't receive a lot of precipitation, so they don't get a lot of rain and they don't get a lot of snow. And dry climates tend to be where we find deserts. So, for instance, the Sahara Desert, right at the top of Africa, is one example of a dry climate. We also have the deserts here in like Arizona area of the States. And then there's the Gobi Desert in China as well, that those are very dry areas. And of course, in Australia, there's like a bunch of dry space there as well. Tropical climates tend to be located along the equator. So you see this line right here. They tend to be located right along that equator. And they are very, very warm and very, very humid all year round, pretty much. Not to mention, they get a lot of precipitation. So they tend to be very wet. So if you take a look at where the Amazon is, it's typically around the equator. The Amazon is a rainforest, and we consider that to be a tropical rainforest because of how close it is to the equator. Lastly, we have continental climates. Continental climates have warm to cool summers, and then they can have pretty cold winters. So when you think of continental, you're thinking Manitoba, Saskatchewan, Alberta here. And in fact, actually, we technically live in a continental climate as well. If you think about our winters, we get pretty cold winters, and our summers are warm, but they're not hot. Now that we have an understanding of climate, let's talk about climate change. So climate change indicates the changes in weather patterns and conditions over a long period of time. Nothing is ever stagnant in nature. Everything is always constantly moving, and it's in a flux. Climate change actually happens naturally, and we've seen multiple times in history, well, I mean, we haven't seen it because we haven't lived that long, but we have measured multiple periods of warm and cold on the planet. We typically call the cold periods ice ages. You might ask, what causes climate change? Why does the climate change? Why doesn't it stay steady? Don't we rotate around the sun at the same speed and at the same angle? Like, what gives? Well, it's actually caused by many factors. Now, the factor that I want to focus on is greenhouse gases. So greenhouse gases are an integral part of our atmosphere. So we have our atmosphere, we have our atmosphere that surrounds our Earth, and it protects us from things like solar radiation and, space rocks and space junk from falling and hitting us and stuff like that. So we have a bunch of different gases in the atmosphere that protect us. Now, some of these gases are what we call greenhouse gases, and they are helping the Earth to maintain its heat. That's their job, is they help to maintain heat on Earth. Because if we didn't have those gases, the heat from the sun would hit the Earth, and then by the time this rotated to the back and we hit nighttime, all that heat would leave and it would be freezing cold at night. So greenhouse gases are very important in regulating temperature between night and day on Earth. So we know that when you increase the amount of greenhouse gases in the atmosphere, that can affect the warming of the Earth. Similarly, if there's less greenhouse gases in the atmosphere, that can help with the cooling of the Earth. How do we know that the climate is currently changing? Well, we have seen it ourselves. We have been monitoring the climate in various places of around the world for the last hundreds of years. Not hundreds maybe, but at least the last 50 years we've been actively monitoring. We have seen that storms are becoming bigger and stronger, droughts are becoming more frequent and more intense, and glaciers have been retreating at alarming rates. When I mean glaciers have been retreating, I mean that the glaciers have been melting. And as they melt, they leave that space that they were empty. So it looks like they are creeping backwards slowly over time. Now, the reason why we are concerned about climate change is that we humans have had a direct impact on the rate of warming of the Earth. We have been burning all kinds of fossil fuels for generations, and those fossil fuels release greenhouse gases. And like I said before, greenhouse gases help to keep the Earth warm. When you put more into the atmosphere, you have more warming. Not only do we burn fossil fuels, but we also cut down a lot of trees. Now you might ask, what do trees have to do with greenhouse gases? Well, one of the big greenhouse gases is called carbon dioxide. And if you remember talking about photosynthesis, you know that trees will take in carbon dioxide and they will breathe out oxygen in return. So trees actually help to remove carbon dioxide from the atmosphere. But if we're cutting down these trees, that means that those trees are not taking in carbon dioxide. So we're actually putting even more carbon dioxide into the air. Now, I do want to make something very clear. Climate change is different than global warming. They're very distinct things. Climate change looks at how the climate is changing. So climate is weather conditions, such as storms, lightning, and that kind of stuff that happen in very large areas. Whereas global warming is specifically looking at temperature. So global warming is concerned about the average Earth temperature. Now, when I say the average Earth temperature, Earth is a big, big, big place. We have temperatures that go all over the place. Like if you measure the temperature of here versus here, you're gonna have a really big difference, right? I mean, this is probably gonna be like -30, -40 maybe, and here we're gonna probably have +30 or +40 degrees Celsius. There's a big difference here. So when we say the average global temperature, we take the temperatures that we would expect from each of the different climate regions, and we take an average based on the surface area around the Earth. Now, global warming doesn't necessarily mean that everywhere on the Earth is warming up. It does not mean that. Global warming itself, we're taking the total average. So when we say that the global temperature rose by 1 degree Celsius, that means that it's the average of the entire world. So, I mean, it could have warmed up by 3 degrees in this region here, could have cooled by 1.5 degrees here, and it could have warmed up by like 2.5 degrees here, but overall it would be, average of increase of 1 degree Celsius. So that's the important thing to remember. Global warming does not mean everywhere warms at the same rate. People ask, why should we be concerned about climate change and global warming? What does that have to do with us? Well, there are lots of things that climate change affects, such as rising sea levels, ocean acidification, stronger storms, desertification, and loss of animal and plant life. Climate change and global warming have a huge impact on the Earth itself. And it's a natural phenomenon, but we have been pumping in carbon dioxide and other greenhouse gases into the atmosphere, and we have increased the rate of climate change. The Earth is not used to that quick of an increase, so the Earth can't adapt as easily. The plants and animals can't adapt as easily. So we're going to be seeing a lot of massive, drastic changes that is not natural. Humans are directly affecting the rate of climate change, and we need to be concerned because if we want our future generations to have access to clean water, to have access to food security, and have a good, stable life, we need to be concerned about what we are doing that affects the Earth right now. That's all for today, and I will see you next time when we talk more carefully about greenhouse gases. Bye!